Alright guys, this is my attempt at trying to explain question 5 after Denise did a pretty good job explaining it to me. I'll see if I can do just as good of a job trying to portray that to you. Basically what you want to start with at the start, like with this thing, I'll just draw it up here. R1, R3, R2, this is total, minus positive, I guess ground, RF, V out, and this is V in. You want to be doing nodal analysis at this point here, and also from here. This is going to be 0, B equals 0, because it's a virtual short circuit across the op amp. And yeah, so let's start, eh? We end up with V minus VI on R1 plus V on R3 plus V on R2 equals 0. If we rearrange this to get V, if I factorize V out, we end up with, what is it? V 1 on R1 plus 1 on R2 plus 1 on R3 minus VI on R1 equals 0. Take that across, we end up with VI on R1 is up V 1 on R1 plus 1 on R2 plus 1 on R3. Pretty much just this on that side, this on that side. So dividing by V, VI on R1, multiplied by R1, God, I hate rearranging stuff. Oh shit, never mind, hang on, I just go like this. My mistake. Divide by this entire thing, you end up with V equals VI all on R1, 1 on R1 plus 1 on R2 plus 1 on R3. Okay. And that seems about appropriate. Now what we need to do from this point here to get our VO somewhere in the equation, we have 0 minus VO on RF plus 0 minus V on R2 equals 0. You have minus VO on RFF equals V on R2. Multiply R2 as VO R2 on RF equals V. Now this is where mine might differ a little bit from others. This is just how I prefer to do it. VI on R plus that plus that. I'll give myself a little bit more room. Multiply, I get RF onto the other side, and then divide by VI. So do it step by step. Minus VO R2 equals VI RF on R1, 1 on R1 plus 1 on R2 plus 1 on R3. Then we have divided by VI, VO R2, that's great, we'll do 2 steps. Divide by VI, divide both sides by VI and R2, spread it with, and negative R2, let's say, VI like this, and we have negative RF on R2 times R1, 1 on R1 plus 1 on R2 plus 1 on R3. And you'll see that this right here is our gain, which means this is our RF, just RF on Ri. So that, which means this entire bottom equation here will be equivalent to RB. Simplifying that. Oh, this is going to be fun. R2 plus, no, this is not too bad actually. R1, because, yeah, I'll do it in multiple steps so you can see. R2 R1 on R1 plus R2 R1 on R2 plus R2 R1 on R3. This and this cancels, this and this cancels. Oh, equals VO on VI. And then we get R1 plus R2 plus R2 R1 on R3. And then that'll be, no, yeah, all on RF. Sorry. VO on VI. So this bottom section here will be our RB, and if we check our little thing, that is that what we get? That is exactly what we get, yes. R1 plus R2 plus R1 times R2 on R3. So that's how we get our value for RB. Which if you sub in the values for this, which I'll do right now, I would have 36 all big factors of 1,000 plus 12 plus 36 times 12 divided by 36, so that's just plus 12. So it's 36 plus 24 equals 60, and we can see here that it is actually correct. So this, our RIB. Now I think that's what it uses to calculate the gain, but I'll have to double check. Calculating RIA, which is the input resistance for these here, you can see going from VI, you end up having R1 in series with R2 and R3 in parallel. So RIA is just going to be R1 plus R2 times R3 on R2 plus R3. If we calculate that numerically, 36 plus 36 times 12. 432 divided by 48 is 9. 36 plus 9 is 45, and we see that here, 45,000, excellent. And now, to determine which one it uses AV, oh, they should both. I don't really understand how this works, to be honest. Doesn't really make much sense to me, because they're both different values for input resistance. So I'll just, they're both negative, so it's both inverting let's try it with RIA first. So 130 on 45. It doesn't look like it's going to be that. Negative 130 divided by 45 is no. Okay, so something to note that your AV will be the it's for figure B if this question does come up. So negative 130 on 60 does in fact equal negative 2.1667. Cool, and that seems to be pretty good. Yeah, this is the last video I'll be putting up for the exam, and I'll put this working. It's kind of all over the place. I'll put it up on the Dropbox. Good luck, everyone. It's, yeah, fingers crossed that they go easy on us this time.